So the first speaker in this session is Professor Christopher Field, who's the director of the Carnegie Institution's Department of Global Ecology, and he's a professor of biology and environmental earth system science at Stanford University. He's trained as an ecologist. He's done work across the world on rainforests, deserts, Americas, Asia, Africa, and Australia. And he's a real leader in global change research. He's best known at the moment by many of you as being the elected co-chair of Working Group 2 of IPCC, which is the working group that deals with the theme of adaptation. And he has won a number of awards, including the 15th Annual Heinz Award. So, Chris, please tell us all about what you want to tell us about.
Thank you, Diane. I knew that 8 o'clock was a brutally early time. I want to congratulate all of you guys for staggering in here. But I have a new appreciation of how brutally early it is since the chair chose to be elsewhere. Anyhow, what I'd like to do this morning is share the experience that we in Working Group 2 and IPCC in general had with a recently published special report on managing the risks of extreme events and disasters to advance climate change adaptation. It's a report that represents a bunch of innovations for the IPCC, and in many ways this is an opportunity for me to share some of the outputs, but also to thank much of the community here. I think that in the history of IPCC reports, this is the one that has been most explicitly focused on the adaptation agenda, and it's one where I think that the adaptation community, including essentially all of you here, have really had a chance to shine in the context of the IPCC. There are really 4 innovations that I want to talk about in the context of this special report. But before I do that, I want to mention that the report's actually doing quite well. The paper version was just released last Friday, and I don't think we've sold a single one. But since the electronic version was posted on March 28th, there have been over 40,000 downloads. I wish I knew how many people had actually read it, but 40,000 sounds like a good number. The innovations that I want to talk about are fourfold. The first is that in order to tackle this topic, we really had to bring together a group of scientists that was broader and more integrated than we have in any previous IPCC reports. There are really 3 fundamentally different communities that were linked in the creation of this team. First is the traditional Working Group 1 community, the people who work on the physical basis of climate change. Second was the traditional Working Group 2 community, the impacts, adaptation, and vulnerability scholars, including essentially all of you. And the third was a group that's new to the IPCC, the community that's traditionally been focused on disaster risk management and disaster risk reduction. And broadening the agenda to include those represented a huge advance in the sophistication of our thinking, but it also represented a huge opportunity. The second innovation was this was really the first IPCC report to centrally feature adaptation. The report has 9 chapters. Of those 9, 4 are explicitly focused on adaptation, on opportunities, on constraints, on scaling, and on the interface between adaptation and development. A third innovation is that this is really the first IPCC report that was focused from the very outset on a framing in the context of managing risks. From the first word to the last word, managing risks is really the core of the storyline around which the rest of the report is built. And in looking at the responses, I think it's clear that it's created a new dimension, an important new dimension to the discussion about managing climate change, and it's also allowed new groups to participate meaningfully in that discussion. The fourth innovation is that for the very first time in an IPCC report, from the initial design stages, we included an ambitious outreach program as a fundamental part of the of the design and framing. Since the report was released the SPM was released at the end of last year, we've had outreach events in about a dozen countries with generous support from the government of Norway. And that outreach has focused on practitioners, on decision makers, and on what we think of as decision makers of the future, young people. The core framing is one that has worked very well for a variety of stakeholders, and it starts from the understanding that impacts of climate extremes are not a consequence of the climate extreme only, but they're embedded in a social matrix that has critical controls that are dependent on the vulnerability of the community and on the exposure. One of the interesting challenges we faced is that from the disaster risk reduction community and the IPCC community, the definitions of vulnerability and exposure were quite different. And in the early stages of the project, as many of you will remember, it was really unclear whether we would ever get beyond definitions. And one of the things that I really liked about the dynamic is that by the end, we really had converged on a series of definitions. In fact, in many ways, we really converged on a dramatically coherent worldview. But one of the things that was nicest is that in essentially all cases, and you can see that here in the definition of vulnerability, we really had converged on definitions that put people and the interests of people central to the dialogue and kind of shifted us away from a framing where the physical climate was kind of the centerpiece around which the rest of the agenda was organized. The context for the whole report was that the risk of disasters emerges from the overlap between the nature and severity of the event, the exposure of the assets and people, and the vulnerability or preparedness. But we also recognize that there was a unifying concept of development that had to include both disaster risk management and climate change adaptation, and that in order to think constructively and creatively about those two agendas, you couldn't really separate them from the broader agenda of sustainable development. So we think of this development complex as impacting both vulnerability and exposure and the prospects for disaster risk. An interesting aspect of the framing of the climate extremes and disasters is that the report doesn't make a big distinction in most aspects between natural climate variability and anthropogenic climate change. They both fit together in a matrix where it's increasingly difficult to say that one is a cause of a particular event. We really live in a new climate regime where essentially everything that's happening is influenced by the anthropogenic changes as well as natural variability. So this matrix of the influences on the nature and severity of the events really combines both anthropogenic and natural variability. And then finally, the framing included the recognition that we're not looking solely at impacts of development on exposure and vulnerability. We also need to understand the consequences of the realization of those in disasters for the prospects for future development and the consequences for vulnerability and exposure, representing a key feedback loop shown by the arrow at the top of this figure. And in addition, it's important to recognize from the start that the adaptation agenda can only take you so far in managing climate extremes and disasters, and that an appreciation of those limits is an important factor in structuring investments in mitigation of emissions, which you can see is characterized by the arrow across the bottom of the figure. One of the most challenging things we had to deal with in the framing of the report is that it's very clear from the history that it doesn't take a huge extreme in order to create a disaster. A disaster really emerges from the overlap of the event, the exposure and the vulnerability, and that in many cases, a series of modest events, a concatenation of different kinds of events, or unfortunate circumstances can lead to a disaster, so that the agenda isn't one of saying from the purely physical climate sense, where are the most extreme extremes and how do we deal with those? It's recognizing that there's this rich texture to the kind of extreme events that lead to disasters. And one of the ways we were able to unfold that in the report was go through a series of case studies like this cholera outbreak in Zimbabwe in 2008. The starting point for the technical treatment was the conclusion that losses from disasters have been increasing. There's no question that if you compare the losses during the 1970s and the losses in recent years, there's been an increase. But it's also clear that if you try and attribute the causal factors for that increase between the different factors that you can imagine, that the dominant cause is an increase in exposure, an increase in the amount and the value of the physical assets that are basically in harm's way. But it's also really clear that that characterization is a very inadequate way to understand the full consequences of disasters, and that in particular, things that are difficult to assign monetary values, human lives, environmental values, social and cultural opportunities, are very poorly captured and are very inadequately represented in a geographic scale. It's also clear that the vast majority of the fatalities associated with extreme events are in developing countries. Here are the economic data on losses, and you can see that a fraction of the losses are covered by insurance and that there is this increasing trend. But it also is really clear that this is only one aspect, and in many cases a relatively small aspect of the overall issue with disaster losses. You can see another aspect of this inadequacy of the economic losses by looking at the spatial distribution of the count of losses in the multicolored bar and in the economic damages in the black bar. There are two important take-homes from the spatial map of disaster losses. The first is that disasters really influence all regions of the world, and that there's no correlation between the number of disasters and the economic losses that are associated with those. And then a final critical aspect of what we can say about the time trend in disaster losses is that there's no link at all between where the economic losses occur and where the fatalities occur, and it's particularly sobering that 95% of the fatalities associated with extreme events are in developing countries. We put a lot of effort in the report in characterizing where we are with the physical climate system, and the trends are really quite clear, strikingly clear, and we have seen trends in 4 aspects of extreme events in the physical climate system. The projections are also quite clear that we're headed for increases in all 4 of these. The 4 trends that we've seen so far are exposures to high temperatures, also associated with heat waves. The fraction of the precipitation that falls in the heaviest rainfall events, this isn't exactly the same as floods, but it's an important precursor for flooding. And in most regions of the world, we've seen an increase in the fraction of the rainfall that falls in these heaviest events. Several places in the world have seen increases in the length or severity of drought, especially true in Southern Europe and Western Africa. And there are many coastal regions that have seen an increase in extremes that are associated with high sea level, basically storm surge. When you look at the projections, they're really quite dramatic. Probably the most dramatic is the projection that's associated with extreme heat events, and what the simulations indicate for the A1B scenario, kind of a middle-of-the-road scenario. Well, we wish it were middle of the road, one that looks very modest in the context of today's emissions, is that toward the end of the century, what's in the current context a 1 in 20-year extreme heat event becomes on the order of a 1 to 2 year extreme heat event. Let me just say that in a different way. We're looking at, with a middle-of-the-road scenario for most land areas, a 10-fold increase in the frequency of the most extreme heat events. A really sobering conclusion. And it underscores the extent to which thoughtful analysis and planning for extreme events really does require a recognition that we're in a dynamic environment. One of the things that was satisfying about the report is that as a consequence of the emphasis on adaptation, we really had a chance to explore many dimensions of what I think of as the solution space, and not only what the options are, what's worked, but also what hasn't worked. And that's been very distributed, looking at issues that impact the weather and climate events, forecasting, mitigation, investments in reducing vulnerability through poverty reduction and education awareness, and through modifying exposure through everything from improving the hardening of structures to relocating assets. I'm supposed to finish up? Is that what your standing there indicates? Okay. My time was taken away, but we can have a discussion about this later, but I do only have 2 slides left. The most important conclusion is that there really are a wide range of investments now that have dual benefits. There are a wide range of investments that can reduce disaster risks in the short term while also contributing to sustainable development in the longer term. And if you look for low regret strategies, investments with high payoff relative to cost, it is indeed those things that have the combined effect of short-term contributions to reducing disaster risk with long-term contributions to providing development benefits. The report is incredibly rich. It's 595 pages of dense information due in large part to the integrity, commitment, and volunteer activities of this community, and I'd like to take the opportunity now to say thank you and to affirm that it's really making a difference. Thanks very much.
And the best thing you can do for Chris is to download that report and read it, because it'll make all the work worthwhile. And a lot of times people are not paying attention to the shift from sort of these 5-year IPCC reports to these special reports, which are really very important. I'm going to ask the remaining speakers to try to speak for 15 minutes, if possible. Mark and Richard could have a little bit longer, but Karen O'Brien is not here because of death in the family, but we have Sebastian Katowski and Chris Gordon, who will make some remarks at the end of the session, but I do have to finish it on time because we have 8 parallel sessions immediately following. So I'm going to make the introduction short because you have them in the, Mark, do you want to start coming up? We have fairly good biographies. This is Mark New from the University of Cape Town, who is going to talk to us about some of the latest developments in climate science and climate modeling. Mark. Can you get him set up? I'm going to wave signs.
So thanks very much, Diana. I think my talk follows quite nicely on, actually, from what Chris discussed earlier. So without further ado, I just wanted to start with a little bit of background context, if I can get this to work. There we go. Okay, so this is a slide, so just talking, that illustrates the issues that one's dealing with when one's looking at climate information or climate data to inform impacts and adaptation work. And I wanted to focus on 2 distinct timescales of that people might want information at, and that's where those 2 grey circles are sitting. The first on a timescale of maybe 1 to 10 or 20 years. So that's sort of adapting to emerging climate risk or emerging climate change, which is very much in the disaster risk field, and also, in fact, timescales of relevance to much of the developing world, where many of the development actions that are happening now and need to incorporate climate information, but people are often not thinking on the sorts of timescales that traditional climate scenarios have been produced at 50 or 70 years in the future. And then the second timescale is much further in the future, and this might be at the timescale where one is making quite large infrastructure decisions, as Maria was talking about yesterday. So the question then is, how do these different timescales actually interact with what Mark Stafford Smith calls decision lifetime? And this is essentially the timescale over which a particular decision plays out. So for example, one could think about a large reservoir. There's a decision lifetime for that reservoir, which is the planning, the design, getting permission, if ever, to build a reservoir, and then the lifetime of the reservoir actually once it's been built. And those sorts of decisions actually can be quite long, so that dark red, very dark red arrow at the top. So there one might need climate information now that informs your decision, because the decision lifetime actually lasts for many, many decades. And then there are intermediate types of decisions. The blue arrows are very short-term decisions. So that might be a farm planning cycle, what a farmer might think about strategically in terms of replacing crops with new vineyards, new fruit varieties, etc. And those have a shorter time scale, but sort of sit in the time scale of where there might be an emerging climate risk. And then there's obviously a series of different questions in between those timescales, depending on the type of decision. So what I wanted to do was talk about 4 different sort of, not advancements, but types of climate model data that are emerging from the climate science community that may actually, possibly provide new information on these 2 different timescales, long-term and shorter term. And starting off with the longer-term climate information, just about everybody in the audience will be familiar with the Coupled Model Intercomparison Project and the 5th version of that, or is it actually the 4th version, I think. But anyway, it's the new set of climate model simulations using global climate models and running out for at least 100 years. And what's new about these? Well, the new concentration scenarios, the so-called RCPs that are driving those, actually, I think from an impact point of view, that it just complicates the situation, makes it more difficult, because it actually makes it more difficult to evaluate past work and actually figure out what the new results are showing in the context of previous impact studies. You have to go back and actually standardize by global temperature for a particular emission scenario to actually end up with comparable results. So I'm not sure that actually helps the impact world very much, particularly as they're just covering roughly the same spread of possible futures, just slightly different emissions pathways. New versions of climate models, definitely higher resolution, but when we talk about higher resolution, we really mean moving from, say, 2.5 degrees latitude, longitude to 1.5 degrees, or maybe, if you're lucky, 0.5 degree latitude, longitude. So there's still a resolution gap between the spatial scale at which the models produce, I guess what you could call actionable information, and the spatial scale at which a lot of adaptation work is going on. Many of these models have new physics in them. There's a question about whether that actually means improved physics or not, or just different physics. And that'll produce different outputs, but then there's a big sort of question around whether those outputs are actually improved or just different. And that's a big area of activity, obviously, with the Model Intercomparison Project with climate scientists. The other new thing that's coming out of CMIP-5 are these high-resolution time slice experiments. So taking particular time slices in the future rather than transient runs and running these same models at high resolution to try and improve the resolution. I haven't seen many outputs from those yet, so I can't really comment on them. And I guess the big advancement in one sense is that there's going to be a heck of a lot more data floating around for the impacts and adaptation community to drown in. Many more variables across a spectrum of different diagnostics, and much more data. So it was actually quite hard previously to get hold of daily data, for instance, from CMIP-3, and if you could get it, it was only for particular time slices in the future. Now much of the daily data is going to be archived, but then you've got to be skilled enough to process terabytes of data to actually get information or outputs that are relevant to your location. So that's sort of what the long-term experiments are going to be producing. The next question is really, so what? What does that mean for impacts and adaptation work? Well, I don't think it means very much. If we look at these two graphs, this is global temperature, global mean temperature. The top graph shows CMIP5, the bottom graph CMIP3, so the previous generation of climate models. Two reasonably comparable scenarios, so the RCP 4.5 and SRES A1b. And what you get is a very similar delta T, change in temperature globally at the end of the 21st century. Slightly different upper and lower limit, but the range is about the same, around 2 degrees. So we haven't actually narrowed that uncertainty very much with this new generation of climate models. We may actually be getting more nuanced information there because climate models have got more processes, higher resolution. Individual climate models may be providing, and probably are providing, more information about processes and why you're getting a particular outcome. But in terms of the spread of possible futures that one has to deal with from an impact point of view, I don't see much change there. Zooming down a bit, this is a representative grid box over Cape Town, where I do a lot of my work now. And this is showing the projected changes in precipitation across those two multi-model data sets, around 20 models each. And again, very little difference in terms of the trend or the size of the range at the end of the century. So again, not much new coming out that makes a step change beyond what one could do with CMIP3. The next thing I want to talk about is something called CORDEX, which is a coordinated regional downscaling experiment. And this, I think, does add value in the sense that it's a coordinated set of regional climate model experiments falling under CMIP5. And particularly from my perspective in the African context, which is a priority area for CORDEX, there's a consistent methodology to generate multiple global climate model, regional climate model simulations at higher resolution than one has from the global climate models. So we have at least 10 regional climate models that are, or climate modeling centers that are generating scenarios over the African continent with standard resolution of 50 kilometers. So quite a big change in resolution compared to the available global climate models. The sorts of results one can then get are something that the US and Europe have had the benefit of for some time through multi-RCM products. But here we have just an example of an evaluation of extreme rainfall, 1 in 10-year return rainfall over southern Africa at a resolution that's been impossible to actually achieve in terms of comparing multiple models previously. So again, one can ask, so what? What do these regional climate models actually produce? Now, this is a horrible diagram. It's called a Taylor diagram, for those of you who aren't IPCC Working Group 1 geeks. But essentially what it's doing is comparing the regional climate models to the real world as represented by observations across 3 variables: the mean, the variance of them, and the spatial correlation. So it's essentially trying to summarize 3 key characteristics of the models in one diagram. Effectively, what that diagram is showing, where that arrow is pointing, is reality. And we'd like all of those regional climate models to be as close to that reality dot as possible across these 3 parameters. That's how close the driving GCM, in this case it's just the reanalysis data, so present-day climate model nudged by observations, is to reality. And this is how close the various regional climate models are that are driven by that reanalysis are to reality. This is over a fairly large region, a region roughly the size of South Africa, so it is aggregating over a large scale. But there's a question then as to whether you're actually, this increased precision that you're getting from these models is actually producing an improved set of climate information if the spread of RCMs you're getting is actually larger and further away from reality than the driving GCM. So there's a question there and a lot of analysis that needs to be done about the information content of these higher resolution models before one can actually start using the data to inform decisions. I want to shift quickly to near-term climate change, and this graph just summarizes the sources of uncertainty in climate model projections, and I wanted to really focus in on that orange curve, which shows the component of total uncertainty that relates to internal variability, or in climate model speak, initial condition uncertainty. And you'll see that curve really ramps up and becomes a significant proportion of the total uncertainty as the lead time becomes shorter and shorter. So essentially chaotic variability in the climate system becomes a big component the closer one gets to the present, because the actual climate change signal is much smaller. So in the context of adapting to emerging climate risk, one of the critical areas where we'd like to have improvements is in actually characterizing that internal variability, or actually having forecasts on decadal timescales that actually incorporate initial conditions to try and reduce that initial condition uncertainty. And this is where another set of experiments coming out of CMIP5 have the potential to do something new and quite exciting. And these are these decadal predictions, which are 10-year and 30-year simulations that are actually initialized with observations of the ocean system. Unlike the long-term projections, which are not sort of initialized or tied into the real world at the start of the projection, these ones actually spin off what our best estimate of the real world is, in the hope of actually capturing some of that decadal variability that's embedded in the climate system. So these are run on a 5-year period, on a 10-year period, and a 30-year period, every 5 years from 1960 to 2005. And we're at the stage of, or the climate science community is at the stage of evaluating these to see what the predictability is of these so-called decadal predictions. So what? Well, here are just some results in terms of global temperature of what these decadal forecasts are actually showing. Each of those blue and red curves is one 10-year forecast. And the black curve is the observed change in global temperature. So you can see some strange things happening there. That bottom panel shows that the first 2 or 3 years, the model just cools off rapidly. And that's actually the model moving from the initialized conditions to its own natural climate. So it's actually just climate drift. And depending on how the model is initialized, that is a serious or not so serious issue. So these models aren't actually, they're currently quite hindered by some of the initialization problems, and perhaps of limited utility at this stage because of that. One can also look at the predictability on different timescales. So this just shows for a couple of models the ability of the initialized model forecasts to actually represent what happened. And everywhere that's red shows quite a high correlation with what happened, and everywhere that's blue or without color shows actually not such a strong correlation. And the interesting thing here is that the highest correlations happen in regions where there's actually not very much decadal variability. So those high correlations are actually the climate change trend, because decadal variability isn't actually screwing up the trend or masking the trend. So what we have here is that at this stage, the predictability on these sorts of timescales is still open to question. And there is a question as to whether these decadal prediction models are actually providing information that's actually useful on these timescales. One way that they might be useful is if one takes somewhere like East Africa, where there's a very consistent model trend of increasing precipitation, but the observed trend that we have at the moment is of drying. So there's a mismatch between what we're observing and what the models are projecting. Maybe some analysis of these decadal forecasts will help us tease out whether what we're seeing is a real reality model mismatch or some decadal variability that's masking out that signal. Okay. So I'm going to skip this final slide and just finish off with this, this question. So what do model outputs, or do model outputs help us with adaptation? I'd pose the Hewitson challenge, and this is one that Bruce Hewitson always ramps out quite controversially. Would you use climate model data to decide where to buy your next house? So if you, as somebody who's knowledgeable about climate science and the outputs of climate models, if you're not prepared to sort of bet your own investment on it, then why should you be asking others to do the same? And I think the real answer is more nuanced than that, because there are multiple factors that make you decide where you're going to buy your house. And there may be some climate information that actually makes you choose between different options. But we're definitely at the stage now where we've got climate information, some of it quite nuanced, that can inform the decision-making process, but probably on which one shouldn't be basing any decisions in terms of a black and white yes-no situation. And I don't think many of these new climate model outputs are going to change that situation very much, although I think there are some exciting possibilities for understanding emerging climate risk that we haven't actually had before. Thanks.
Thank you, Mark. So it looks like Chris wants to be the enforcer and I still have to be the introducer. So the next speaker is Richard Klein from Stockholm Environment Institute and Linköping University. I'm making that up, I think I know that. And Richard is one of the leaders in climate adaptation research, and I'll also give a shout out to his journal, Climate and Development, because he's looking for great papers. So Richard, thank you.
Good morning, and thanks for showing up. For me, it's early. I'm jet-lagged, but I know some of you aren't. Thanks to Diane and others for inviting me to talk about an issue that is somewhat uncomfortable. It is about self-reflection. It is about realizing that perhaps as a community, we can actually do better in conducting our vulnerability, impact, and adaptation research. Now, I'm not here standing on a high horse and telling the community how to do things better, because I'm very much part of that community. And I think that we do need to understand that we are maturing as a community. And there used to be sentences in papers saying that adaptation research is still in its infancy. I don't think we can say that anymore. So I think we need to move on and accept the challenge that we need to perhaps become more rigorous in how we do our research. And I'll try and give some ideas as to what we and how we might go about that. So about maybe 20 years ago or so, as the adaptation research field emerged, I think it was fair to say that there were about half a dozen to a dozen adaptation researchers, and around the time of the third assessment report of the IPCC, they got together and wrote one chapter based on the very limited literature that existed at the time. Now we are here with 700 people. I think there are many more adaptation researchers out there who aren't here. So the community has absolutely grown, and there are more and more adaptation researchers, and we are producing more and more adaptation research. Are we getting any wiser? Are we doing better? Are we giving better information to those who rely on the adaptation research? This is a diagram that Martin Perry showed yesterday, or something like that, where based on the IPCC fourth assessment report, showing various impacts for different sectors based on different temperature trajectories. And as he demonstrated yesterday, there is an adaptation challenge on the left, there is a mitigation challenge on the right, but those don't meet. There is a gap in the middle that, if not filled, would result in the residual impacts. Now, bridging that gap very much depends on the availability of good information that is actionable and informs adaptation that reduces those impacts. Research to do that has been ongoing for quite a while, and I'm just giving you one example could have really picked many examples of a vulnerable region that has attracted attention for a long time. And I apologize if typeface is rather small, but it shows that from the late 80s, pretty much every year or so, there has been a study assessing the impact and vulnerability of the Nile Delta to sea level rise. And this is only looking at publications in the peer-reviewed literature. There are many more book chapters, conference papers, and agency reports that have looked at the same question. And what's interesting is that when you look at the very first papers in the late 80s and those that have been published just very recently, in terms of approach, in terms of method, they're really not that different. The graphics are more fancy. The data is perhaps somewhat more detailed, and we've got longer time series. But we're talking about the same question, the same results. And it sort of raises a question, why are we actually doing that? Why aren't we able to learn from earlier studies? Suppose that we were astrophysicists or quantum mechanics. You think that we would be able to get papers published by basically doing the same thing that was done 20 years ago, by ignoring methodological progress that was made earlier and not citing it? These are the kind of maps that were produced in the late 80s and are still being produced. Of course, you can also then raise the question, to what extent does that help reduce the vulnerability of people living there? Now, as I said, I don't want to sit on my high horse and just blame the community for not doing a good job. I think there are many reasons as to why rigor may be compromised. And this is just a brainstorm over the past few days, and I think there are probably other reasons and justifications. We do face the challenge that adaptation research is not a scientific discipline per se, but a combination of many different disciplines, and we come together and have to learn each other's language and concepts. And it does make it more difficult to embrace particular theory or to develop new theories, rather rely on existing theories that we might not necessarily be very familiar with from our own background. I think it's also fair to say that there is an enormous demand on the research that we are doing, and that pushes us to try and produce as quickly as possible. There isn't actually much time, other than perhaps for PhD students, to go to the libraries or do your research online and read what has been done earlier and try and build on that. There's enormous time pressure that we impose ourselves, but is also imposed on us by those demanding the research. And then there's competition between researchers for funding, for prestige, for publication space in good journals. And I have the impression that sometimes that stops us from being self-critical and honest. And we go to meetings like these, we would like to emphasize how successful our project was, how useful, how important. I also noticed from several of the presentations yesterday that we tend to explain why we do certain projects or ask a certain question, present the results, but don't actually say much about the methodology, why we chose that methodology, and what problems we encountered and what we might have learned from that. There's a disconnect between research and action. That's something it's also related to the lack of time, to the spatial scale. There's many different types of disconnects, some that are unavoidable, but the kind of information that we are producing and the kind of information that practitioners, policymakers can use to make better decisions isn't always the same. There's conceptual confusion, perhaps related to the fact that we come from different backgrounds. Just to give one example, the term climate resilient development is very much in vogue. I'm not even sure whether that originated in the academic community or more from the likes of the World Bank and DFID. When you look at how it's been interpreted and used, climate resilient development for some has much to do with low carbon development, in other words, mitigation of climate change. For others, climate resilient development has much to do with adaptation. I think if we can't be clear and rather be imprecise and hand-waving about these concepts rather than be precise, I think is really problematic and doesn't help us in making progress. What's the responsibility of researchers? What's the responsibility of the users of the research is a difficult question, especially in those research activities that are participatory by nature, or action research. This is not me saying that one shouldn't do action research or one shouldn't do participatory research. One should do that. It's very important. But at the same time, one has to also realize the particular responsibility as an academic to draw conclusions that are not biased by the interaction with particular individuals, for example. Ideological motivation, the extent to which a particular question is addressed not or informed not necessarily by the data and information that is collected, but more by a particular agenda, whether that is a neoliberal one or a Marxist one. I think that is something that one comes across occasionally. What I really want to focus on in the rest of my talk is the final issue, that the use and choice of methods is sometimes rather uninformed, partly because we might not be aware of the important theory, partly because we are familiar with particular methods and don't have time to familiarize ourselves with other methods. And the choice of methods is also linked to why are we actually looking at impact, vulnerability, and adaptation? What is the purpose of the assessment? And this is work that's been very much pioneered by Jochen Hinkel in Germany, who emphasized the importance to link the choice of methods with the purpose of the assessment. And there are different reasons why academics do vulnerability assessments, there are different reasons why users or stakeholders are interested in information about vulnerability. It could be the purely academic question as to what are the dynamics of a system, what actually makes people, communities vulnerable. It could be to inform further analysis, to make decisions about priorities. It could be to raise awareness of the problem. Much of the impact and adaptation studies, or I should say impact and vulnerability studies of the 1990s have actually not so much informed adaptation. They weren't necessarily intended to inform adaptation. They were intended to raise awareness among policymakers to get their act together on mitigation. It showed that, yes, impact and vulnerability are going to be dramatic if one doesn't actually reduce greenhouse gas emissions. But of course, increasingly, we're also doing impact and vulnerability analysis to inform the adaptation process. I think about 10 years ago, there was a tendency in the community to say, but vulnerability is unique, every place is different. You can't possibly have one approach or one methodology that applies to everyone, because all communities are different, all the stresses are different, and it doesn't make sense to try and impose particular methods. And I agree with that, but the pendulum has swung in a different direction to the point where everything was possible. Let 1,000 flowers bloom. There are many different methodologies, if you would like to call it that way, or approaches to assess impacts and vulnerability and adaptation. And there hasn't been the rigor, there hasn't been the quality control that I think a serious academic community should have been responsible for. Now, the field of climate change vulnerability assessment has absolutely mushroomed. I just did a quick Google Scholar search yesterday. Now, this is publications that have the words climate change vulnerability assessment, not necessarily in that order in it, but 176,000 is absolutely amazing, and just close to 6,000 just for this year. Many of the studies, and as Diana said, I'm editor of a journal, Climate and Development, so I see quite a few of the papers that are submitted to the journal, and they're not explicit about why these studies have been done. Sometimes they don't even have a method. They don't actually describe the method by which they have gone about their research. Yesterday morning, one of the young scientists, Laura, made a very impressive presentation, I thought, and one of the things she said is that science is always expanding and its methodologies are always developing. And yes, that is indeed in general the case, but from the list of publications that I showed from the Nile Delta, and again, I could have shown many other examples, one can ask the question whether that is necessarily the case in the vulnerability, impact, and adaptation field. Steve yesterday suggested that we need to move from information to knowledge, and this is one way of doing it. When we come to the choice of methods and why we choose particular methods, That was a challenge that PROVIA, the global program of research on vulnerability, impact, and adaptation, that was introduced yesterday also by Martin and Salim. It was a challenge that PROVIA wanted to pick up and make sure that the use and choice of methods was indeed going to be more robust and more rigorous. There is guidance to inform the assessment of vulnerability, impact, and adaptation research. That guidance was prepared in 1994. So you can imagine that things have changed over the past 80 years or so, and a revision of that guidance was in order. So we're actually working at the moment to prepare a revised guidance. There is a draft available. I'll come back to that in a minute. A group of authors, 3 of them are here in the audience, Tim Carter, Kate Lonsdale, and Sandy Bizzaro. If you want to talk to them, they can give you more details. I coordinate this particular activity. The idea, the rationale for doing this is that planning and implementation of climate adaptation should be based on a solid understanding of impacts and vulnerability. And that solid understanding needs to be based on the right choice and solid application of good methods. There are 3 elements that make up that guidance, or the draft guidance as it is now. And an important innovation is that there's quite a bit of emphasis given to the framing of the question. Why are you doing this? What do you need to consider? And that framing takes place by running through a number of decision trees. The user can, and I'll show you an example in a minute, decision trees that can help the user to understand the particular circumstances and information and knowledge needs that need to be fulfilled. Then there's an important section about the approaches and methods and tools for vulnerability, impact, and adaptation assessment, depending on the decision trees enter then that particular section. And then how does one use the knowledge that comes out of that assessment to inform adaptation, the adaptation process, using examples of good practice. So this is an example of one of those decision trees where you start off on the left with a particular decision that needs to be made that leads into tasks, and they then lead to particular methods. That is sort of the overall scheme, perhaps better when I show you an example. One of the decision trees in the draft guidance asks the question, is there data on observed impacts? In some cases there will be, in some cases there won't be. So depending on the question, you then end up in a different box. And every time you pass a blue box, there is a reference to a particular section that then presents the methods that could be used to fulfill that particular task. As I said, there is a draft available at the moment, and this is the community really that is able to comment on that. And I would very much encourage and invite you to have a look at the document and not be intimidated by its size. We think it's very accessible despite its size. And have a look and see if you can help us in providing feedback by the end of June. Now, to wrap up, is this guidance then a response to that pendulum swinging in from the one imposed approach to let 1,000 flowers bloom? I would say no, this isn't going back from let 1,000 flowers bloom to the one approach, because the PROVIA guidance that we're preparing is not prescriptive. There are many different methods that the user could choose from depending on where they end up in the decision tree. It provides guidance in selecting those methods and its application based also on the purpose of the assessment and the circumstances of the user. At the same time, though, this only addresses one of the various factors that I started off with that I think lead to an occasional lack of rigor in our research. So the guidance alone cannot guarantee the enhanced rigor of the future research, but there's one factor, one contribution to that. The other factors need to be addressed as well. So I'll close with some recommendations. The first is, despite the fact that we are an interdisciplinary lot, research needs to be based on theories, and even the lower level, bottom feeding interdisciplinary journals like the one that I'm managing would like to see those theories being referred to, used and applied in the research. Also, do build on previous work. You know, those people doing the research in the 1980s and 1990s did have some very good ideas, and it would be a shame to reinvent the wheel and waste time doing that when you can actually build on their work. Be conceptually precise. Be clear what you mean when you talk about vulnerability, exposure, risk, and so on. And let's not confuse ourselves with more hand-waving on particular conclusions. Also demonstrate the relevance of your case study beyond the local level if you are working at the local level. Of course, that's a community-wide responsibility to make sure that the added value of the broad knowledge base that's being divided is indeed multiplied and provided to the user and stakeholders. And finally, as a link to the ideology-motivated or blurred research, understand the difference between action research and activist research. We can talk about that more in the discussion. Thank you.
Okay, I want Mark and Richard to publish those papers as soon as possible because they were very challenging, and I would make them the first two papers that any new graduate student in this area should read, because they both raised really, actually quite disturbing questions about what we do, but also gave us some hope. So what we're going to do now is we've got one final paper from Sebastian Katowski, and then Chris Gordon has very kindly said that he'll just make a few comments to wrap up the session. So our next speaker is Sebastian. He's the head of adaptation for the Adaptation Subcommittee of the UK Climate Change Committee. And this is really an example of where this sort of research is going to the very highest level and some of the challenges in doing that. So Sebastian, thank you very much.
Thank you very much. Thank you, Diana, for the introduction and also for the invitation. It's been a very interesting conference for me so far. We don't get out very much, and it's nice to see that other people are actually wrestling with some of the same challenges that we're wrestling with in the UK. So I'm going to talk a little bit about some work that we've been doing to think about how you can measure progress in adaptation. Sort of as Richard just alluded to, adaptation has matured both as a research discipline, but also as a policy area. And as that's happened, I think there's been more emphasis and interest in how can we actually evaluate what we're doing? Are we making sensible decisions? And can we or should we be changing the way that we do adaptation policy specifically? So, as Diana said, I work for the UK Committee on Climate Change and the subcommittee which is focused on adaptation. And this was set up under an Act of Parliament to provide a monitoring role on how well the UK is doing in meeting its climate change challenges. The focus was initially on mitigation, on identifying carbon budgets that the UK should live within, but almost as a little bit of an afterthought, but a good afterthought, they included an adaptation component. And we're there both to provide advice to the government about the risks and opportunities from climate change based on the latest research, but also to report on progress in how well the UK is adapting. We have a committee chaired by Lord John Krebs and various other distinguished researchers and experts, including Martin Parry, who many of you will know. So when I started the job a couple of years ago, initially I think everyone was relaxed about adaptation, but I think when I started working on it, we quite quickly realized that actually it's quite a much more difficult challenge than mitigation, particularly in terms of measuring progress. How can you objectively say whether an institution, an organization, or a national government or a regional government is actually adapting well, preparing well for the challenges from climate change? And there are, I mean, this has been rehearsed before, but just to remind people why adaptation is harder. Firstly, obviously, there's no clear target or metric against which you can judge adaptation. How do you best measure risk or vulnerability, as Richard was talking about? Of course, for mitigation, you can measure the carbon emitted. But also, for mitigation, we've got a good sense of how the activities underway that we do, the things we do, the cars we drive, the power we use for electricity, how they relate to carbon emissions and what they lead to and what the main factors are. For adaptation, that's much less clear-cut. And also, there's more uncertainty about the future scenario. So what exactly are we adapting to, and how can we therefore judge whether we're making sensible decisions? And I think the other tricky area with adaptation is that it's very context specific. So the right adaptation decision for a particular local community will be very different from another local community. And therefore, how can you assess whether these are the right decisions? So we started to get interested in indicators and whether indicators can help you measure progress. And I think the first thing we realized is there's many, many different types of indicators. And again, a bit like Richard was saying, people are using impact indicators, vulnerability indicators, adaptation indicators in all sorts of different ways. And just to give you a brief sample of some of the ways that people have used indicators, and the first sort of the classic way that indicators were used were to measure the impacts of climate change. So can we observe a signal of climate change? And here's one that probably many of you have seen before, which is how many times the Thames Barrier, which protects London from flooding, closes every year, either due to coastal tidal events or from fluvial events, river flood events. And we can argue about whether there's a trend or exactly what's driving this. But that's one type of indicator that people have started to use is, can we measure the date that different tree species might leaf out in the spring, or the migration of species. So those kinds of climate impact indicators, which I think are useful from a climate change perspective. From an adaptation perspective, they're perhaps not the best place to start with. But also people then started thinking about, well, can we measure the capacity of organizations to adapt? And here's some work that was based on actually an indicator that the previous government in the UK set up, which was an indicator about local authority progress in adaptation. And here you can develop indicators to look at where local authorities are in the sort of in the activities on adaptation, whether are they moving from just getting started and thinking about the problem to actually full-on implementation and reviewing and taking in kind of risk assessment and action planning. And you can see from blue is 1 year and red is a second year that you can see some progress. But again, these indicators, they're useful to a degree, but they're often self-reported. They can be slightly subjective as well. The third kind of indicator, which is actually some work that Benjamin Preston did at Oak Ridge National Laboratory, and I think he's speaking or presenting some work later at the conference, is can we measure the plans or policies or strategies that different either countries or organizations have in place and basically count them. So here's a study that Benjamin did comparing Australia, the UK and the States, and different kinds of strategy documents, consultations and plans that they have in place. And often when you do these kinds of studies, you see, I think again, as Richard alluded to, a sort of exponential rise in the number of plans and strategies that countries have in place. So certainly in the UK, we found that there's sort of plethora of policy documents that use the word adaptation. But when you start to scratch beneath the surface, you often see that these documents can just pay lip service to adaptation, but don't actually materially reduce our vulnerability to climate change. So we had a sort of conceptual phase of thinking about this a bit, as Chris Field mentioned. Actually, we did use the sort of IPCC framework. I think we were using the term sensitivity instead of vulnerability. We were using a slightly older version. But essentially, we thought about a framework that really put adaptation and vulnerability at its heart, and thought about indicators that tell you whether your exposure, sensitivity or vulnerability is changing, but also indicators that help you think about the actions that you're taking, but the actions that are actually affecting the outcome, which are actually the climate impact indicators. And of course, climate change comes up in the grey box at the top. So that was our kind of basic sort of framework for thinking about this, which is challenging enough. So for different sectors, can you identify indicators in each of these categories? And more importantly, can you demonstrate that actually the indicators you've chosen do actually have a material and a strong link to a reduction or management of climate risk? And that's the sort of tricky area, because the kind of indicators you choose could direct policy in the wrong direction if you don't choose indicators that actually do play an important role, either in moderating exposure and sensitivity or in enhancing adaptation actions. But actually, indicators by themselves are not just enough. And actually, I'll show you that indicators, you can start to collect indicators, but it's actually interpreting them and thinking about what they really mean that's the tricky part. How do you decide how much adaptation is appropriate once you've decided on the adaptation action that you want to monitor? But also, how do you think about how the decision-making process is actually incorporating climate change into the process? And from that, can you identify barriers and the right policies to unlock adaptation? So I'll just talk you through some of the ways that we've actually tried to implement the toolkit, because actually it's only when you start really trying to use these kinds of tools that you start to understand where they're useful, but also where they're challenging. So the first, well, actually I'll talk about a couple of risks in the UK. So one is rising risks of flooding, and the second sort of interspersed is the rising risks of droughts and water shortages. And everyone thinks it rains a lot in the UK, but actually certainly the east of the UK is we're very dry compared to many other places per capita. So for flood risk, you can start to identify indicators that will increase your exposure, so building in the floodplain, paving over green space, which means that the water runs off faster. You can also identify action indicators, so flood defences, how much are we spending, how many properties are seeing a benefit from the flood defences, how many properties are actually putting in measures to protect themselves from flooding, and then the number of developments that are putting in sustainable drainage systems and those sorts of things. So we... just to show you a few of those, for development in the floodplain, we see that actually in the UK, it's been pretty constant over the last 10 years or so, despite actually having a planning document that says we're going to encourage everyone to adapt. Actually, the number of homes in the floodplain is continuing at about 10 to 12% per year. And we're also seeing an increase in the amount of hard surfacing at the expense of green space. So this is just based on a sample of a few local authorities. You can see the amount of natural area, the green bars have gone down over the last 10 years, and the amount of man-made surfaces have gone up. On a more positive note, we've seen household water consumption, which for water resources is starting to go down. That's the green line. Mostly driven by households that are metered, so people that actually pay for the amount of water that they use. Amazingly, people again are surprised by this, but about 60% of the households in the UK, actually you just pay a flat rate for the amount of water you use. So there's absolutely no incentive to save water for those 60% of households. We've also looked at things like leakage and the improvements in reducing water leakage in the UK, and it's kind of plateaued over recent years. And at the same time, we've also looked at the kind of actions you can take to manage the risks of flooding. So how many new developments are putting in raised floor levels or sustainable drainage that can help you. But here it starts to get more difficult because it's harder to know how effective those measures are and whether they're quite the right measures. And that's where we've had to bring in some more economic analysis. So this is an adaptation cost curve, which some of you may have seen, that McKinsey, I think, pioneered a few years ago, which looks at the amount of sort of cost savings that you get on the x-axis from a particular measure and the cost-benefit ratio, and everything below the 1 level makes sense to do from an economic perspective. So there are a range of measures that you can do to protect your property from flooding, and they save you a certain amount of money, which is on the x-axis. Yes, a couple of minutes, yeah. The second, and the other thing we've been starting to do now is combine our work on indicators with an understanding of how the risks of climate change will change in the future. And we've been able to do that now because the UK has just published its first national climate change risk assessment. And here you can start to look at, well, the measures that we're taking, so that will be the orange bars, which is reducing consumption from 150 litres per person per day to 130 litres. How much of the risk does that remove? And depending on the climate scenario you use, it removes between, say, a half to a third of the risk. So you can start, decision makers can start to use this to think about how much risk are they planning for, and how much risk are they willing to accept, or do they judge they can't afford? And finally, you can use indicators to sort of tell you how far you're getting. So when we look at the uptake of water metering in the UK, where will this get us in 20 years' time? Will that be fast enough? Do we think that 80% of households having meters by 2035 is enough? Do we think we should be going faster? Are we relaxed about this? So I think all the indicators, you can start to use them in quite interesting ways once you've established them, which is not completely straightforward. And actually, I think we started them for floods and water. We're moving into other sectors like the natural environment and agriculture, where I think we're going to find it even more difficult. So just to sum up, I think we're finding that indicators are a useful way that you can start to answer some of the tricky questions about monitoring and evaluation for adaptation. And from talking to people at the conference, it seems that other people are having similar conversations and also similar challenges. So we're very interested to learn from the work you've been doing as well. Thank you.
To have a few minutes discussion, and Chris is going to begin with a few remarks. Thank you, Sebastian. Both Mark and Sebastian's presentation made me very glad I was able to sell my house on the Thames floodplain a couple of years ago. So, Chris.
How much time do we have? Up to the 9:30?
I would say we should probably only try to go for about 8 minutes so that people can go to their session.
Okay, well, in that case, I think what I would like to do, rather than spend time giving my own view of the presentations, which I'm sure several people on the panel know already, let me open the floor up for questions and clarifications. So we have time for about 3. So please, yes, come to the microphone up here if you have any intervention, clarification, or question you would like to address to the panelists. So that's number 1, I think. Any other? Okay, sir, please go ahead.
I'd like to ask the panel to address the near-term and far-term ellipses that Mark had on his chart. I'm asking this from a user perspective in terms of looking at the longer-term adaptation measures where the challenges get higher towards the end of the century, but then also that transition phase of the near term and how one might, approach addressing both.
Anyone?
Well, in the IPCC report, we thought in terms of more or less dividing the future into an adaptation time frame where things that are put in place now can really make a difference, and a more distant time frame that represents a more nuanced, richer combination of mitigation, adaptation, sustainable development, and in many cases brings in the concept of societal transformation where you really run into limits. And at least in the view of the scholars who contributed to the IPCC report, there's a lot more we can say about the short-term investments and a lot better feel we can get for their costs and benefits, but that the best way to think about the future is to focus on the integration of the adaptation, sustainable development, and opportunities for transformation.
Okay, thank you very much. Any other panel member want to add anything to that?
I could just say, I think the Thames Barrier example is a very interesting example of how to deal with those different timescales. So this was planning for what the Thames Barrier should be like in 2100, and the approach adopted was very much a flexible pathway option, in the sense that you don't lock yourself into anything that's too expensive or too big that ends up potentially being a maladaptation later on. So in terms of that transition phase, I think the options one takes up in that transition phase should be those that build in maximum flexibility going forward, if and when the actual climate change signal becomes big. So it's a bit of a kind of, sounds like a bit of a US perspective, do nothing until the evidence becomes better, but do things that don't screw you up when the evidence becomes better, I think is a better way of putting it. Yeah.
Okay, thank you. Any other intervention from the floor? As they say, speak now or forever hold your peace. Okay, in that case, I made a few observations about the various presentations. I think for Chris, the fact that the losses from disaster are increasing, the fact that fatalities are greater in developing countries, and the tenfold increase in extreme events makes me want to ask a question. If you have a class where you have 50 A pluses out of 100, does A plus become the extreme? If you've got 1 out of 2 events being classified as extreme, doesn't that mean you have to now shift your parameter of what extreme means? For Mark, he had this very, I think, useful concept that new does not mean improved. Given his surname, I mean, but I think it is an important point that we tend to follow various trends because they seem innovative, but really, as Richard also commented upon, there's a lot of very good work done in the late 80s, which we shouldn't forget. The scaling issue, I think, is something that is very important because when you're talking about adaptation, you're looking at local level decision making. And when your scales are of the thousands of square kilometers or thousands of square miles, it's very difficult to get the decision makers to buy in. Richard made a very important point about the disconnect between research and action. And we are hoping that the Provia, with its decision support mechanism, will help bring methods that are applicable, because this has been the big question that I'm asked. I happen to be leading the development of the Ghana National policy on climate change, and I'm dealing with ministers and decision makers all the time, and basically they're saying, well, you people are just talking. You're not telling us what we need to do to change things. And they want things changed rapidly, which sometimes doesn't work. But we do need to get down to the action. I was impressed by the work done in the UK, but again, the big problem you have with the decision makers is this issue of uncertainty. A politician wants to be 100% certain. He does want to go on to the stage and be told, well, last week you told us this was going to happen. It didn't happen, so we don't believe you any longer. And this issue of credibility based to uncertainty is a problem that I think all adaptation specialists need to face. Now, Diane will kill me if I go 1 minute over the 9:30. It is actually 9:30 by my recently purchased American mobile phone. So with that, ask you to give the panelists a round of applause. And thank you very much for your attention. Okay.